Good morning, everyone. Let us start this session. So, in the previous session, we have seen the Pascal law, and we have seen how the pressure intensity remains same from all the direction at a point in a static fluid. Okay. So, we have seen this with one derivation by considering one triangular fluid element in a static fluid. So, for the Pascal law, so this is the static fluid in one container, and we have considered there is one fluid element, triangular shape. Okay. And the Pascal law is the pressure intensity at a point in a static fluid is equal in all directions. Okay, so in order to prove this, we have considered one fluid element in a static fluid. And these are the pressures, which is a Py in the y direction. This is Px, and this is the Pz. So finally, from the derivation, we arrive at this equation. Px is equal to Py, this is equal to Pz. Okay. So from this equation, we can see if the fluid is static, then the pressure or the pressure intensity at a point in a static fluid is equal in all directions. Okay. So from this equation, we can write, suppose we have the arrangement like this. So suppose we have one plunger and this is the ram on other side. Okay, so we apply the force F on this plunger, and on this ram there is one dead weight which is to be lifted. So this dead weight is W. Okay. This ram, it is having the cross-sectional area as a A1, and this plunger is having the cross-sectional area A1, and this ram, it is having the area as a A2. Okay. So when we apply the force M, the pressure is created. So the fluid. So pressure is created on this fluid because of the force F, and it is transmitted on the other side. Okay. So this pressure, it is same on this plunger and on this ram. So here we can write the equation. Pressure is equal to the force upon the area of the plunger as a A1, and at this point the pressure on the ram, this is equal to the force, that is nothing but the dead weight W, and the area of the ram, which is equal to A2. Okay. So according to Pascal's law, in the static fluid, pressure remains constant. So we can write the equation F upon A1, this is equal to W upon A2. Okay. So by using this equation, we can find out if we apply the force F on the plunger, how much weight we can lift on other side. Okay. So finally you will get the equation W is equal to F into A2 upon A1. Okay. So this principle or this equation, it is used while designing the jack used to lift the heavy load, okay, or the hydraulic jacks. So this is the basic equation for the hydraulic jack or the hydraulic rams. So now we will see the hydrostatic law. So hydrostatic law, it gives the pressure variation across the depth in a fluid. So it is about the pressure variation across the depth or along the height in a static fluid. Okay, so we will derive the equation for the pressure variation across the depth. Okay, so for that, consider one static fluid. So this is the free surface of the fluid. Okay, so in this fluid, we consider the fluid element like this. So actually, this is cylindrical fluid element. So in a 3 dimension, so this is the fluid element. Okay, so this fluid element, its height, this is equal to delta z, and its cross section, this is the delta a. Okay, so this fluid element, it is at distance z from the free surface. So this distance is z with respect to free surface for this layer. This height of that fluid element is a delta z. Okay, now the pressure on the top surface or the top layer of that fluid element. So here we have the pressure as a P, and the pressure variation along the z direction. So this is given as del P upon del Z. Okay, so this is the equation for the pressure variation along the Z direction, and therefore the pressure at distance delta Z. So this pressure, this is equal to, so on this surface we have the pressure P, which is the original pressure. Okay, so total variation, so we will write here pressure variation. So pressure variation at distance delta Z, this will be delta P upon del Z. So this is the pressure variation across the Z direction. So if the length is delta Z, total pressure variation is equal to del P upon del Z into delta Z. And therefore pressure or total pressure at the bottom surface of the fluid element So this is equal to, at this point we have the pressure P. So it is P plus del P upon del Z into delta Z. So this is the total pressure at this point. Okay, so we can write here P plus del P upon del Z into delta Z. This is the total pressure. Okay. So now we will write the force equilibrium. So just I will draw the fluid element. So for the force equilibrium, we need to convert this pressure into force. Okay. Now this pressure, it is acting on this area, which is a delta A. So corresponding force, this is equal to, so pressure, this is equal to force upon area. So force is equal to pressure into area. This is the general equation. Okay. So from this equation, we can write here the force is equal to pressure is P into area is delta A. So this is the pressure or a force on the top surface. On this bottom surface, we have the force. This is equal to, now at this point, we have this total pressure. So it is P plus del P by del Z into delta Z into area is delta A. So this is the total force. And also there is a weight force due to this fluid element and it is acting in the downward direction. So this weight, this is equal to mass of the fluid element into gravity G. So this mass, this is equal to density into volume, because density is equal to mass upon volume. So mass is density times volume into G. Okay, so rho is the density. Now what is the volume of this fluid element? So observe this diagram. So volume is, height is delta Z and cross section is delta A. So this is equal to delta A into delta Z into G. So this is the weight force. Now write for the equilibrium as the fluid is static. So as the fluid is static, so there is a equilibrium. Okay. So using the equilibrium condition, so this is static equilibrium. Using equilibrium condition, so there is no force in the x direction. So just consider summation Fy, and this is equal to 0. So for summation Fy, we have the force P into delta A in the negative direction. So minus P into delta A. Then this is also negative, minus rho delta A delta Z into G, and plus P plus del P upon del Z into delta Z into delta A is equal to 0. Okay. Now from all these equations, we can cancel out the delta A. Okay. So here you can write the equation as, you can take the negative term on the right hand side. So we will have the equation. This is P plus del P by del Z into delta Z, and this is equal to P. So take this term on the right hand side. So it is a P, and this term, this is plus rho into delta Z into G. Okay. So we can cancel out this P value. Now the remaining value is, even you can cancel out this. So it is del P upon del Z into delta Z. This is equal to rho G into delta Z. So this value we can cancel out. So remaining value is del P by del Z. This is equal to rho into G. Okay. So rho into G, this value, this is called as the weight density. This is weight density of the fluid. Okay. So what does it indicate? The change in the pressure in a vertical direction is equal to the weight density of the fluid at that point, and this is called as a hydrostatic law. Okay. So from this equation, which is a del P by del Z, this is equal to rho G, and this is nothing but the weight density. So from this equation, we can write the rate of increase of pressure in vertical direction is equal to the weight density of the fluid, and this is nothing but the hydrostatic law. Okay, and from this equation, if you integrate that equation, then we will get the pressure at a particular point. So if you integrate this, you will have the equation. This is the del P is equal to rho G into del Z. Just integrate this equation. So you will get P is equal to rho G into Z. Okay. So the meaning of this equation is, so consider we have the static fluid like this. This is the free surface. And at a particular point, so consider this height. This is point A in that static fluid. And it is at distance Z from the free surface. Okay, let us take Z is equal to 2 meters. And this fluid is nothing but the water. So this is the water. So if you want to find out pressure at this point, so PA, so we can write the equation PA is equal to rho G into Z. Okay, or rho is nothing but rho water, G, and Z is nothing but this total distance, which is equal to 2 meters. Okay, so rho is 1000 for the water, G is 9.81 into 2. Okay, so you will get the total value for the pressure in terms of Newton per meter square. So this is the use of the equation, okay, which we get from the hydrostatic law. P is equal to rho G Z, or sometimes it is written as rho G H. So H is nothing but height of that particular point with respect to the free surface of the fluid. Okay. So this is rho G H. And this pressure, it is given in terms of Newton per meter square. Okay, so sometimes instead of this Newton per meter square, the pressure is expressed in terms of meter only. Okay, so this is called as the height of the fluid column at a particular point. So from this equation, we can write H is equal to P upon rho G. And this is given in meter. Okay, so when you measure the pressure by using the U-tube manometer or the piezometer, then sometimes pressure is given as a meter. Okay, that is the height of the liquid column. So in that case, pressure is expressed in terms of meter only. Okay, so this is all about the hydrostatic law. We should remember this formula: P is equal to rho G Z or P is equal to rho G H. So we will see this application of the hydrostatic law when we will discuss the pressure measurement devices. Okay, that is a piezometer, U-tube manometer. So now we will solve some problem on the Pascal law, which is P is equal to force upon area. Okay, so this is your basic equation. F1 upon A1 is equal to F2 upon A2. So just note down the problem. A hydraulic press has a ram of 30 centimeter diameter, and it has a plunger which is 4.5 centimeter diameter. Find the weight lifted by the hydraulic press. Find the weight lifted by that press when the force applied at the plunger is 500. When force applied at the plunger is 500 Newton. Okay, so what is given? So we have the hydraulic press. So its construction will be like this. I will just draw the schematic diagram. So this is the ram. So on this ram, there is a weight which is to be lifted. Okay. In order to lift this weight, we have the plunger arrangement like this. Okay. So on this plunger, we will apply the force, which is the F. So plunger will create the pressure on the fluid like this. So this is the fluid. Now this pressure, it will get transmitted through this fluid and it will act on this ram. Okay. So that pressure will create the force, and then this weight will be lifted. Okay. So here we will use the Pascal law. That means the pressure is equal in all the directions. Okay. Or the same pressure is transmitted through this fluid and it will act on this ram. So at this point, we have the diameter. So consider this diameter as a D1 and this is equal to 4.5 centimeter. Okay. Or we can write this 4.5 10 to the power minus 2 meter. For the ram, it is having the diameter. This is a D2 and this is 30 centimeter, or this is 0.3 meter. Okay. So consider here the pressure as a P1. So this pressure is created due to application of the force F. So we can write pressure P1, this is equal to force upon the area, which is a A1. Now force is given as a 500 Newton upon area is, now this plunger, it is a circular cross section like this. So this is the area. So this area will be pi by 4 d1 square. So this is pi by 4 and d1 is equal to 0.045 square. Okay. So you will get some value for the pressure P1. So this is equal to 314,380.13. This is Newton per meter square. Now at this point, that is at the ram, consider the pressure P2. So P2, this is equal to, now what is the force here? In order to lift this weight W, the force created by this pressure, it must be equal to the weight W. Okay, or it is greater than that weight. So we will consider the limiting condition. Okay, so this force, let us take this F2, it must be equal to W. So here the equation will be F2 upon the area is A2. So consider this is F1. So that F2 will be W upon the area is A2. So this is W upon pi by 4. This is also circular in the cross section having the diameter 0.3. So it is pi by 4 0.3 square. Okay. So this is equal to W upon 0.0706. We know that the pressure intensity is same. So P1 is equal to P2. So from this we can write, we have the equation for P1, which is 314380.13, and this is equal to P2, which is equal to W upon 0.0706. And then you will get the weight W. So that is equal to, so this is 22,222.2 Newton. Okay, or in terms of kg, this weight will be, this is 2,265.26 kg. So this much weight we can lift by applying a force of 500 Newton. Okay, so if you observe, this is the application of this equation, which is P1 is equal to P2. So if you observe, we are applying a very small amount of force, which is a 500 Newton. Okay, but this force gets amplified on the other side and it can lift a weight of 22,222. Okay, so almost it is 45 times that of the original force. Okay, so with the help of very small force, we can lift the large weight. Okay, so by using this law, and on this equation, we design the hydraulic press or the hydraulic jack, which is used to lift the car. Okay, so now we will solve one problem on the hydrostatic law. So here the problem given is an open tank contains the water up to a depth of 2 meter, and above it an oil with specific gravity zero point 0.9 for the depth of 1 meter. So question is find the pressure at the interface and second at the bottom of the tank. Okay. So this is the tank. So it contains the water like this. And this height of the water, this is given as a 2 meter, up to the depth of 2 meter. Okay. Above the water, there is a liquid, there is an oil with specific gravity 0.9. So this is the oil. So this oil, it is having the depth of 1 meter above the water. Okay. So question is we have to find out the pressure or the pressure intensity at the interface. Means if you connect one pressure measurement device at this point, then what is the pressure? So this is the interface pressure. So let us assume this as a P1, and second at the bottom of the tank. That means if you select the point here, then what is the pressure? So let us take this as a P2. Okay. So this problem, it is based on the hydrostatic law. So we have the equation pressure at any point in the static fluid. This is equal to density, gravity into the height of that point with respect to free surface. So first we will try to find out the pressure at this point. Consider this is 1 point and this is the point 2. So at this point, just measure the height above this point. Okay. So this height is equal to 1 meter. So H1, this is equal to 1 meter. Then what is the density of the fluid above this point? So above this point, just we have the oil. And for the oil, density is not directly given. What is given? Specific gravity is given. That means S value is given, which is equal to 0.9. And we have already studied in the properties how to find out the density. So density is equal to specific gravity into 1000. So this is density of the water. Okay. So therefore, this is equal to 0.9 into 1000. So this is density of the oil. And this is equal to 900 kg per meter cube. And now we can find out the pressure at the interface. So this is equal to P1 and this is rho oil into G into H. So this is 900, 9.81 and H above the 0.1. So this is only 1 meter. So this is equal to 8,829 Newton per meter square. Now next we have to find out the pressure at the point 2. So for the point 2, what is the total height of the liquid above the point 2? Okay. So now here we have to consider this total height. Because above the point 2, we have two liquids or two fluids. One is water. It is having the height 2 meter. Above the water, we have second fluid, which is a oil, having the height 1 meter. So H2 is equal to is 2 plus 1. So this is 3 meter. Okay, but here for this total height, we have two different liquids or two different fluids. Up to height 2 meter, we have water, and above that we have the oil. Okay, so instead of taking this 3 meter, we will write the formula for P2 as, first consider this height, which is only for water. So this is rho water. Use the same equation into G into H water, that is a water height, plus above that we have the oil. So this is the rho oil into G into H oil. Okay, so for the pressure 2, first we are calculating the pressure due to water, and above that we have the oil. So this is equal to rho water, this is equal to 1000 into 9.81 into what is the HW? This is 2 meter plus this equation rho oil. So this is equal to 900 into 9.81 into H oil. This is 1 meter. So this quantity we have already calculated. This is 8,829. So this total answer is equal to 19,620 plus 8,829. So this is equal to, so this is the total pressure at the point 2. Okay. So this is the P2 value. So this is how you can find out the pressure in a container for the static fluid having two different fluids. Okay, so note down this second problem on the hydrostatic law. So statement is, if pressure intensity at a point in a fluid is 3.924 Newton per centimeter square, then find the corresponding height of the fluid when fluid is first water and second oil of specific gravity 0.9. Okay. So suppose we have one static fluid in a container. Okay, so initially it is filled with the water. So this is the water. At a particular point, just select a point in that fluid. Suppose at this point we are measuring the pressure. Suppose that pressure is PA. Okay, and we got that pressure PA. This is equal to 3.924 Newton per centimeter square. So question is, what is the height of this point with respect to the free surface? So let us assume this height to be h. Okay, so we have to find out this height. So we will use the hydrostatic law. P is equal to rho g h. So P is given. So this is a PA, which is 3.924. So this is Newton per centimeter square. Okay, so you can convert this value in terms of Newton per meter square. So how to convert that? So 3.924 upon, so this is in Newton, convert centimeter into meter. So this is 10 to the power minus 2 and square. Okay, so this is equal to 3.924 into 10 to the power 4. Okay, so actually it is 10 to the power minus 4. In the numerator it will become plus 4. So multiply by 10 to the power 4. This is equal to, now The fluid is water. So rho will be 1000. G is 9.81 and H is unknown. Okay. So from this you can find out the H value. So this H value, this is equal to 4 meter. This is for water. Now just change the liquid. Okay. So if you replace this liquid by the oil, which is having the specific gravity 0.9. So for the oil, use the same equation Pa, which is a rho oil into G into H. So pressure is same. Okay. We have to just find out the corresponding height for the oil. So pressure will be 3.924 10 to the power 4. Rho oil will be its specific gravity 0.9 into density of water. This is the density of the oil. Okay. Into 9.81 into H. So again calculate H value. So H is equal to 4.44 meter. Okay. So for the water at 4 meter height, we will have the pressure equal to this value. And for the oil at distance 4.44, we will have the same pressure. Okay.